Imagine dragging this really heavy, like super expensive telescope miles out into the pitch black desert.
Right, getting far away from the city lights.
Exactly. You get out there, you set up your tripod, you're calibrating all your lenses, and you're just waiting for your eyes to finally adjust to the dark.
Which takes a while, yeah.
It does. And then, only then do you realize that the absolute biggest source of light pollution in the entire solar system is just hovering right above your head.
Oh, the worst feeling.
It really is. So welcome to this deep dive into your personalized stargazing forecast for the week of July 25th to July 31st, 2026.
I'm really excited about this one.
Same. Because today, the mission is basically to map out the night sky for you. We're cross-referencing all these local celestial forecasts, NASA's orbital tracking data, and deep sky meteor charts.
Which is so important because treating the night sky like just this static, unchanging painting is basically the fastest way to miss the actual mechanics at play. It's this incredibly active ecosystem up there. And when you actually synthesize the NASA tracking data with these localized meteor forecasts, a very specific narrative emerges for this late July window.
Yeah, you've got competing celestial events and shifting visibility.
Exactly. And even a few massive celestial bodies that are actively hiding from you, just based entirely on orbital geometry.
Okay, let's unpack this. Because I like to think about it, well, treating the night sky like a massive free movie theater.
I like that analogy.
Right. Because if you show up at the wrong time, or you just look at the wrong screen, you miss the main event entirely.
You wouldn't just walk into a movie halfway through and expect to get the plot?
No, of course not. Stargazing requires the program. And to start scheduling this week out for you, we have to look at the absolute biggest spotlight in the sky right now.
A moon.
The moon, because its changing shape dictates, like, quite literally everything else we can or cannot perceive through our atmosphere.
Yeah, the moon is absolutely directing the visibility schedule this week, like, no question.
So what are we looking at right now?
Well, the NASA data places us starting today, so Saturday, July 25th, at a first quarter moon.
Okay.
And in terms of sheer illumination from our vantage point, it's about 76% lit.
Which is already pretty bright.
It is. But over the next few days, we are going to watch that apparent brightness just escalate in a way that feels almost aggressive.
It's a really steep climb. I was looking at the charts, and so today it's 76% lit. Tomorrow, Sunday, it jumps up to 84%.
Right.
Then we hit the work week, and it transitions into that waxing gibbous phase. We hit 91% on Monday, 96% on Tuesday.
Just keeps climbing.
Yeah, pushing to 99% by Wednesday night, until we finally hit the full moon, 100% illuminated on Thursday, July 30th.
And even carrying over into Friday, I mean, it's still glowing at a massive 98%.
But here's the thing. Looking at the observational charts you brought in, they are practically begging the listener to pull out their telescope this weekend.
Yes! Highly recommend it.
Not on Thursday when it's full.
Right, definitely not.
So wait, why is the first quarter moon, which is visually only partially lit from Earth, considered a better observational target than a massive 100% illuminated full moon?
It does seem weird at first.
It feels totally counterintuitive. It's like, I don't know, turning on the massive stadium lights for a night game and suddenly seeing fewer details on the field because it's just washed out.
That's actually a really good way to put it, because what's fascinating here is the topography of the moon itself and just the physics of how light interacts with a vacuum.
Okay, break that down for me.
So when you look at the moon this weekend at that 76 or 84% illumination, you are looking at a sphere where sunlight is striking the surface at this really sharp grazing angle.
Like it's hitting it from the side.
Exactly.
Yeah.
Along what astronomers call the terminator line.
The terminator line. Sounds intense.
It just means the dividing boundary between the day and night sides of the moon. And because the moon lacks an atmosphere, there's no air to scatter the light or soften the edges. A grazing angle of sunlight casts impossibly long, crisp, pure black shadows right across the craters and the mountain peaks.
Ah, so it's basically a masterclass in contrast.
Exactly.
Without atmospheric scattering, there's no twilight, no dusk. The shadows on the moon are just absolute voids of black.
Complete darkness in those shadows.
And so those black voids next to the sunlit peaks are what give the surface that rugged three-dimensional pop when you look through a lens.
It creates immense depth. I mean, you can physically trace the jagged rims of impact craters like Copernicus or Tycho, literally just by following the shadow lines.
That's amazing. But then what happens on Thursday?
So fast forward to Thursday's full moon. The orbital geometry has completely shifted.
Right.
Earth is now positioned roughly between the sun and the moon.
Okay, so they're in a line.
Yeah. So from our vantage point here on Earth, the sunlight is hitting the lunar surface straight on at a 0-degree phase angle.
It's like taking a flash photograph directly in someone's face.
Yes,
All the facial features just get completely flattened out by that direct burst of light.
that is exactly it. And in planetary science, we actually call this the opposition surge.
Opposition surge.
Yeah, when a rough surface is illuminated directly from behind the observer, which is us, the shadows cast by the rocks and craters are literally hidden behind the rocks and craters themselves.
Oh, because the light is pushing past us straight into the
Yeah.
craters.
Right, so the contrast vanishes entirely. Plus, the sheer amount of reflected light at that 0-degree angle just peaks dramatically. The craters blend into this flat, blindingly bright, almost featureless disk.
It just washes itself out.
Exactly. So the tactical advice from the celestial forecast is very clear.
Yeah.
Maximize your lunar observation this Saturday and Sunday.
While that Terminator line is still carving deep relief into the surface.
You got it.
Okay, so if that brilliant, blinding moon is acting like a giant spotlight and washing out its own surface details later this week, how on earth are we supposed to see anything else in the sky?
That's a fair question.
Like, what is actually bright enough to punch through that kind of lunar glare?
The planets. Yeah. Even with the moon escalating toward 100% illumination, planetary apparent magnitude is generally high enough to cut right through that light pollution.
Okay, well, that's good news.
It is. The celestial charts actually show 4 out of our 5 naked eye visible planets putting on a really distinct show all 7 nights of the week.
Assuming you know where to look.
Right, provided you know where on the ecliptic plane to look.
Well, 4 out of 5 is an incredible ratio. Let's break down the mechanics of this planetary parade.
Let's do it.
Starting with the inner track, we have Mercury and Venus. Now, the forecast flags Mercury as bright and best viewed tonight, Saturday.
Yep, tonight's the night for Mercury.
And Venus is exceptionally bright, peaking on Friday.
Super bright.
But both of them share a very specific, restricted schedule, right? You can only catch them high in the sky right after sunset or just before dawn.
Right, that restriction is a direct result of their inferior orbits.
Inferior meaning inside Earth's orbit.
Exactly. Because Mercury and Venus orbit between Earth and the Sun, their angular distance from the Sun, which astronomers call their elongation, is severely capped from our perspective.
Meaning they can't stray too far from the sun visually.
Exactly. They can never physically appear in the midnight sky. They are perpetually tethered to the sun's glare.
Oh, that makes sense.
So we basically rely on these periods of greatest eastern or western elongation to catch them just as the sun dips below the horizon or right before it breaks the horizon in the morning.
That geometry makes total sense. They're essentially just hugging the sun's airspace.
Yeah, that's a good way to phrase it.
But as we move further out into the solar system, we kind of get away from that twilight restriction.
We do.
The forecast shows Saturn offering moderate visibility, best seen on Friday, and sitting comfortably high in the dark night sky.
Saturn is great right now.
And then we have the undisputed standout of the week, Mars.
Mars is commanding the mid-sky this week.
He really is.
Its current orbital position places it far outside the sun's immediate glare, which allows it to rise prominently.
So you don't have to race the sunset to see it.
Exactly. You don't have to fight the residual twilight scattering to observe it at all. You can just step out on a clear evening, look up, and easily identify that steady, non-twinkling reddish hue.
It's just demanding attention up there.
It is.
But, reviewing this orbital data, Mercury, Venus, Mars, Saturn, it was a glaring, massive omission here.
Oh, I know what you're going to say.
We are missing Jupiter.
Yep. Jupiter is out of the picture.
And I need to push back on this because Jupiter is a gas giant with a massive albedo. It reflects a tremendous amount of light.
It does.
It's basically one of the brightest objects in the night sky. So how does something that massive and that bright just disappear from the forecast for an entire week?
So it comes down to a phenomenon called solar conjunction. Because you're right, Jupiter hasn't dimmed, and its albedo certainly hasn't changed. But right now, Jupiter's vast 12-year orbital track has carried it to a position where it is almost directly in line with the sun from Earth's point of view.
Here's where it gets really interesting. Because, Jupiter is like an A-list celebrity with a massive entourage, right?
Totally.
But they are avoiding the paparazzi By standing directly in front of a giant military-grade searchlight.
That's spot on.
We know the celebrity is there. We know exactly where they're standing. But the sheer photon output of the searchlight makes it totally impossible to perceive them.
And if we connect this to the bigger picture, that searchlight effect is entirely local to Earth's atmosphere.
Wait, how do you mean?
Well, when the sun is above our horizon, its light hits the nitrogen and oxygen molecules in our atmosphere and scatters in every direction.
Right, really scattering.
Exactly. That phenomenon, Rayleigh scattering, turns our entire sky into a bright blue dome. So Jupiter is up there in the sky right now, literally during the daytime, tracking right alongside the sun.
It's up there right now.
It is. But the localized scattering of sunlight in our own atmosphere completely overwhelms the faint sunlight reflecting off Jupiter's clouds.
Wow. It's just a humbling reminder of scale, isn't it?
It really is.
The absolute magnitude of our local star completely erases the apparent magnitude of the largest planet in our solar system, just because of our atmospheric filter.
Just because of some nitrogen and oxygen.
Which means, if you're keeping score at home, target Mercury tonight, make a date with Mars, Venus, and Saturn on Friday, and just don't even bother looking for Jupiter.
Save Jupiter for later in the year.
Yeah. But this brings us to the ultimate tension in this week's forecast. We have the local solar system locked in, but what about the deep background?
The deep universe.
Right, because looking at the meteor and deep sky charts, we are facing what looks like a major celestial conflict.
Oh, it's the deep sky dilemma.
It really is.
Because from a purely seasonal and orbital perspective, late July is arguably the premier window for deep sky observation in the northern hemisphere.
It's the best time of the year?
You have the galactic center positioned perfectly, and you have Earth intersecting major cometary debris fields. But the atmospheric mechanics we just discussed regarding the moon are going to act as a massive spoiler.
Let's lay out the menu of what is actually happening up there, because the deep sky charts for this week are incredible.
They're packed.
First, July offers the brightest, most dense views of the Milky Way core of the entire year.
Yep.
We are talking about looking due south around midnight, straight into the Sagittarius A-star region. That cloudy, majestic band of billions of stars and dark dust lanes that you see in professional long-exposure photography.
It's stunning.
And on top of that, the meteor charts highlight the Delta Aquariid meteor shower peaking late in the month.
And the Delta Aquariids are fascinating because you are essentially watching the kinetic energy of the solar system in real time.
Oh, that's a cool way to think about it.
Yeah, as Earth plows through its orbit, it's passing through this dense trail of cosmic debris left behind by Comet 96P Machels.
Right.
And when those tiny fragments of rock and ice hit our upper atmosphere at, thousands of miles per hour, they vaporize.
They just burn up.
Exactly, leaving these beautiful, persistent, glowing plasma trails across the sky.
The Milky Way core and a barrage of vaporizing comet debris. I mean, it sounds breathtaking.
It's an incredible show.
But the mandatory condition for perceiving these phenomena is darkness. Total, unadulterated, black sky darkness.
Which is not what we have this week.
No, which is exactly what the NASA lunar data says we are losing day by day. By Thursday, July 30th and Friday, July 31st, we are staring down the barrel of 100% and 98% illuminated full moon.
Right.
The deep sky forecast notes very specifically that this moonlight is going to completely annihilate our ability to see faint stars and meteors.
Because we're dealing with the exact same atmospheric mechanism that hides Jupiter during the day, just scaled down.
Rayleigh scattering again.
Rayleigh scattering. Because the moon doesn't produce its own light, obviously. It acts as a mirror for the sun.
Okay.
So when that 100% illuminated lunar mirror beams sunlight down into Earth's atmosphere on Thursday night, those photons hit our atmospheric gases and scatter.
So instead of a blue daytime sky.
It creates this hazy, glowing white veil across the entire night sky.
Man. So what does this all mean for you, the listener, if you've marked your calendar for the Delta Aquariids?
It's tough.
It's like trying to watch a delicate, intricate firefly show while someone parks their truck facing you, turns on the high-beam headlights, and just leaves them running.
That is painfully accurate.
You know the fireflies are out there in the field, but your eyes physically cannot process their faint bioluminescence through the overwhelming glare of the headlights.
Yeah.
The delicate structure of the Milky Way core, erased by the white veil, the quick, subtle plasma trails of the Delta Aquariids, completely swallowed.
And this raises an important question about timing and patience in astronomy. It creates a profound shift in perspective when you think about the distances involved here.
How do you mean?
Well, To observe the core of the Milky Way, you are trying to capture light that has been traveling across the vacuum of space for roughly 26,000 years.
26,000 years.
That ancient starlight finally reaches Earth, and in the very last millisecond of its journey, it is completely overpowered and washed out by light bouncing off a local rock that is only 1.3 light seconds away from us.
Oh my God. That is staggering. A 26,000-year journey completely derailed at the finish line by our own moon.
Yeah, it's a harsh truth about amateur astronomy.
It really is. You can buy the most expensive light-gathering telescope on the market. You can drive 3 hours out into the darkest, most desolate desert to escape city lights.
And it won't matter.
It won't. If you don't synchronize with the lunar calendar, our own localized space rock will just ruin your deep sky viewing party. The moon owns the sky this week.
It dictates everything. And this highlights the necessity of strategy in astronomy. The meteor forecast explicitly advises to, quote, plan deep sky viewing for later in the week.
Oh.
Or specifically, to hunt for the brief temporal windows when the moon is physically blocked by the Earth.
So wait, if you absolutely must try to catch a Delta Aquariid meteor this week, what do?
Your only viable window is the few hours before the moon rises, or the brief period after it sets, depending on your local horizon.
You really have to thread the needle.
Well, you just have to adapt to the physics of the system.
Right.
If you try to brute force stargazing on Thursday night looking for the Milky Way while the full moon is straight overhead at zenith, you will be deeply disappointed.
Yeah, don't do that.
The smartest approach is to pivot. If the moon is pumping out enough scattered light to monopolize the atmosphere, lean into it.
Oh, I see.
Thursday and Friday are the nights to put away the deep sky charts and just focus entirely on lunar cartography.
Right. Because even without those crisp Terminator shadows we talked about for Saturday, a full moon at 0-degree phase angle is still a staggeringly beautiful object to observe.
Oh, absolutely.
Without the heavy shadows, the variations in surface albedo really stand out. You can clearly map the large, dark basaltic plains, the lunar Maria, against the brighter, heavily cratered highlands.
And it's the perfect time to trace the ejecta rays.
Ejecta rays.
Yeah, the bright streaks of pulverized rock that blast outward from relatively recent impact craters like Tycho.
Oh, I've seen those in pictures.
Right, under direct illumination, those radial streaks become incredibly prominent, just stretching for hundreds of miles across the lunar surface.
Okay, so let's synthesize all these charts, calendars, and orbital mechanics. Let's give you your final actionable cheat sheet for navigating the night sky for the week of July 25th to July 31st, 2026.
Okay, let's recap.
Go for it.
Tonight, Saturday, is your prime window for interplanet geometry. Look for Mercury right around sunset or sunrise. And tonight and tomorrow are also your absolute best nights to break out the optics and explore the moon's terminator line while it sits at 76 to 84% illumination.
Capitalizing on the lack of an opposition surge to find those deep, inky shadows and jagged mountain peaks.
Exactly.
Then you coast through the early part of the week as the moon swells in size and the atmospheric scattering increases.
Right.
When Friday rolls around, you have a major planetary appointment. You are looking for Venus hugging the twilight, Saturn sitting high in the deep night sky, and the absolute standout of the week, Mars shining steady in red right in the mid-sky, totally dominating its visual space.
Beautiful. And finally, your strategic workaround for the deep background.
Ah, yes, the 26,000-year-old light.
Right. If you are hunting for the light of the Milky Way core or the vaporizing comet trails of the Delta Aquariids, you must actively avoid the Thursday and Friday full moon glare.
Because the Rayleigh scattering will just wash them out entirely.
Completely. Plan that deep sky viewing for the localized windows when the moon is hidden beneath your horizon, or delay it until the moon wanes next week.
It really is just an intricate mechanical dance up there.
It really is.
You've got inner planets sliding in and out of twilight based on their elongation.
Yeah.
You have Jupiter swallowed whole by solar scattering.
Hiding in plain sight.
Yeah, and you have the moon growing from a highly textured, shadowed landscape into a blinding spotlight that changes the very nature of our atmosphere. And behind it all, the deepest, most ancient parts of our galaxy are just waiting for the local lights to turn off so they could be perceived.
And, you know, the tension between localized light and deep space darkness is really the underlying narrative of all observational astronomy.
Wow.
We so often look at the night sky as a permanent, unchanging fixture. But cross-referencing these forecasts proves beyond a shadow of a doubt that it is a dynamic, shifting ecosystem.
Everything affects everything else.
Exactly. The visibility of one celestial body is constantly dictating the visual survival of another.
An ecosystem where the brightness of our local moon actively silences the center of the galaxy, where our local star completely erases a gas giant thousands of times larger than Earth just by lighting up the nitrogen in our air.
It forces you to realize that visibility in the cosmos is not a given. It is a temporary privilege granted by orbital timing and geometry.
Which leaves you with something profound to really mull over.
Yeah.
The next time you step outside and look up at that massive free movie theater, consider not just the brilliant actors you can easily see on the screen.
Think about the physics of what is currently hiding behind the glare.
Think about the silent, invisible giants, the localized daylight hiding distant planets, and the ancient galaxies, all just waiting for the perfect alignment, waiting for their brief, scheduled moment in the dark.
Beautifully said.
Thanks for joining us on this deep dive into your celestial forecast. Keep looking up, and we'll catch you next time.